Okay, this is the Binomial Theorem Part 2 screencast, just building off of what the first screencast was going through. The first screencast was to help you discover the binomial theorem or the pattern in expanding binomials, and now I'm going to take you farther. You've been expanding simple binomials so far, but this pattern extends to any binomial. Consider the expression 2x plus 3y quantity squared. The expanded form of this expression has the same structure as a plus b squared if we make a equal to 2x and b equal to 3y. Fill in the blanks below and then simplify the expression. So a plus b squared we know is a squared plus 2ab plus b squared. And right here we can just fill in what we have substituted for a and b. A is 2x and b is 3y. Now I'll simplify this as much as I can. And there I have the simplified form of 2x plus 3y quantity squared. Number 19. Consider the binomial 4a minus 5b cubed. Write the expansion below, combine like terms. As before, in the previous scenario, let's make a substitution. Since this expression contains a's and b's, let's do a different substitution. We'll make x equal 4a and y can equal negative 5b. And now we're looking at what's x plus y to the third power. If you remember from before, the pattern here is going to be 1, 3, 3, 1. And if you don't remember the 1, 3, 3, 1, we could still get it by thinking about if we have 3 letters and we want to choose 3 x's, this is 3, choose 3. If we have 3 letters and we want to choose 2 x's, that's 3, choose 2, 3, choose 1, 3, choose 0, because there's no x's in this term. And now we can make the substitution into these x's and y's for what x is actually representing and what y is representing. There's the structure ready to be filled in, and now I'll plug in the values. And then finally we're just going to want to simplify these as much as possible, applying these exponents and multiplying terms together. Here's one more step to make sure you can clearly follow how to deal with the exponents, the squaring and the cubing. And then lastly we would have this. When you look at the final result, it's impossible to see the 1, 3, 3, 1 pattern anymore. That's why it's important to organize your work and kind of just go through step by step, thinking about what does x plus y cubed look like, and then realizing that x and y are like buckets that we can put stuff in, and things we're putting in are a 4a and a negative 5b. And then we just work on the algebra of simplifying these expressions after that. Let's do another one. Number 20. Now consider the expression 2x plus 3y to the 7th. What is the fifth term in the expanded polynomial? Well, in the expression a plus b to the 7th, the fifth term is a cubed b to the 4th. The coefficient of this term is 7c3. What is the numerical value of 7c3? Well, you can do this by hand, or you can do it with a calculator. If you type it into a calculator, you get 35. If you did it by hand, it would be 7 factorial over 3 factorial times 4 factorial, which is 7 times 6 times 5 times 4 factorial over 3 factorial times 4 factorial. These 4's cancel out. 3 factorial is 3 times 2 times 1, which is 6, and that leaves 7 times 5, or 35. And now part B. In the expression 2x plus 3y to the 7th, the fifth term is blank, and then 2x cubed, 3y to the 4th. In this blank, we would put the 35. We've done the calculation for that. And then just to make it clear for you, when we look at 2x plus 3y to the 7th, if we think about it as a plus b to the 7th, then the fifth term is a cubed b to the 4th. A is 2x cubed, b is 3y to the 4th. So we have the something cubed, something to the 4th. And now I just simplify this as much as you can. I'll show this in steps. And there's the final result. Number 21. Expand the binomial 2xy minus 7 to the 4th. Combine like terms. The coefficients, if you look back at your previous work, you can find them there, or you can, if you don't remember them, it's okay. You can still figure out what they would be. It's the first term is going to be 4, choose 4, and then 4, choose 3, 4, choose 2, and then going on down from there. And then you could type those in the calculator. You can do them by hand. They are 14641. Once you have that, we can set up the structure for the terms in this expansion. Before I simplify this, I want to point out some of the patterns that we have in here. We have the 1, 4, 6, 4, 1 coefficients, and then a descending pattern in the exponents to the fourth, to the third, to the second power, to the first, and then no 2xy term. And then the -7 term goes upward. There's no -7 term to the exponent of 0, exponent of 1, 2, 3, and then 4. Simplified, it would look like this. All right, so that's your final expression. You definitely would want to use a calculator on that. That's a lot of multiplication, and there's no really, I don't think there's any need to do that by hand. Okay, let's look at number 22. Find the fifth term in the expansion of 2x squared plus 3y cubed raised to the 9th power. We're looking for the fifth term, so let's look at the progression in the terms if we were to write them out. The first one would be the 2x squared to the 9th, and then 3y cubed to the 0. So we don't really include that one because it would be 1. And then after that, the second term would be 2x squared to the 8th, and then 7th, 6th, 5th. 1, 2, 3, 4, 5. So now we can start building the fifth term. 2x squared to the 5th power, then the 3y to the 3rd would be to the 4th power, and this leading coefficient would be 9, choose 5. Or, if you remember what we talked about earlier, there's some flexibility to this. We can think about how many ways we can place 5 of one part or 4 of the other part. 9 choose 5 or 9 choose 4. Turns out they're both the same. And now we'll just plug that into the calculator. And there you can see the final simplified form of this fifth term. All right, number 23, and this will be the last one in this lesson. Find the seventh term in the expansion of 4x cubed minus 5y, all of that raised to the 12th power. Well, if we think about the exponent progression, the first term is going to have a highest exponent of 12, then 11, 10, 9, 8, 7, 6, and there's our 7 right there. If I count it out just to confirm, I have 1, 2, 3, 4, 5, 6, 7. So the seventh term is going to have an exponent of 6. And by exponent of 6, I mean it'll be 4x cubed to the 6th power. And that means the other part would be negative 5y to the 6th power as well. And then this leading coefficient would be 12, choose 6. Now this time I'm not going to simplify that. If you've gotten this far, you probably understand how to type that into the calculator, and the numbers get really large. I just want you to mainly understand how to set these up. Thanks for listening to this. If you've gotten through both of these screencasts, I hope you feel like you understand how to expand binomials and the patterns that come out of that.